So I'm Bill Hallstark, the Technical Manager for National Fiber. Here we have built up what we think is just a really simple, super insulated wall using the materials that we're all kind of familiar with, but in a way that, we've also used these materials in these type of assemblies since the first double wall assemblies started coming out in the early 80s. We're now just making them basically thicker at this point. So basically we have drywall on the inside, insole web. So we like the insole web because this gives us a way to monitor the quality control of the density of the cellulose. So we're going to inject the cellulose behind the insole web and we can actually feel the density. As we get a larger cavity, we actually have to increase the density so that the material remains self-supporting. So in a 6-inch wall, we'll be at 3.5 pounds per cubic foot. At a 12-inch, we'll be at about 4 pounds per cubic foot. And once we get up to 18 inches, then we're pushing that 5 pounds per cubic foot density. We have an expanded bag coverage chart available to our installers so that they can monitor how many bags they've gone through, know the square footage, be able to calculate beforehand to make sure that we're achieving those densities.
How does that density impact conductivity?
Yeah, so as we increase the density, we do start squishing out those air pockets, and the R value does drop slightly. What we're gaining from that is that resistance, that self-supporting behavior of the cellulose, as well as additional airflow resistance. So at 1.5 pounds per cubic foot, we're about 3.8 per inch. When we get to 3.5 pound density, we do drop off to about 3.65 per inch at that density.
Hypothetically, if I had a balloon frame wall that's like 18 feet tall,
yes.
What am I looking for density and a resulting?
So the self-supporting nature of it at that higher density means that in any column, I can actually remove the bottom of that column of insulation, and the upper insulation will not fall down. That's what we feel is self-supporting. Anything short of that is something that's going to be prone to having problems down the line. So an 18-foot column, it could be infinitely, it's going to be supporting itself basically laterally in there and not have any impact coming down.
So we're looking at 3.65.
3.65, yes.
What does it drop to at 5 pounds?
At 5 pounds, we actually, you've gotten us a little off guard here. We haven't tested the material at 5 pound densities. If you followed that same curve, it's down, probably 3.5 or 3.5 per inch, maybe even a little lower than that at the 5 pound density. A couple other things that you're gaining on this is that 14.5 inches of cellulose in a vertical assembly will outperform a wood fire block. So we have integral fire blocking. The cellulose has been approved in the 2012 codes as meeting the fire block requirements. So that means that on our tall walls or balloon frame walls, all of a sudden now we don't need to have some conductive piece of material going through. The cellulose truly can be, in there all the way from the basement all the way up. The borates that we use, so one of the important things about your cellulose is it being all borate. The boric acid not only is a great fire retardant, but it also resists insects, and it has antimicrobial qualities. The blended product, sometimes you'll see that the lesser price cellulose materials will have ammonium sulfate. Ammonium sulfate, the problem with it is in the presence of water, dissociates into ammonia and sulfuric acid. So we'd like to keep those things kind of out of our buildings. The borates certainly are very stable. They're going to give you a good performance over time. On the outside of this assembly, we have plywood, which tends to be very forgiving in terms of moisture. In fact, it changes its characteristics as moisture increases, becomes more moisture permeable. We want to make sure that we seal. A lot of what we're doing is actually exterior air sealing all the connections between the exterior sheathing. There's less of those connections. It's actually easier to seal them on the outside. And then, finish off that with some tar paper, some furring strips in your siding, and you have, a 100-year wall here that is high performance, and yet any builder can construct a wall like this, and it's out of just pretty standard materials. We do like this tape coming out of Europe here, the Tescon. It is moisture permeable, which is be good to have that on the exterior of the building so we're not building up any moisture on the back side of it. It also has a really aggressive adhesive where you can't peel that off once it's stuck on nice and tight.
Awesome. Well, I think your time's up.
Okay, thank you very much.
Excellent.
Good seeing you.
Fantastic.